So I guess there's probably quite a few people in the room, certainly there is at our other consultation meetings, that aren't really sure what this is all about, really. You know, it's good for Scotland, for the internet, and what peering all about. So what we usually do is have almost an introduction to peering. So first up, Andrew's going to come and talk you through that. What peering is all about.
Okay, good afternoon. Thanks. I just thought I'd introduce myself, really. I'm MD at Extraordinary Networks, which we're a cloud hosting company that's been going about 11 years, headquartered in Edinburgh at the Gyle, and we operate out of data centres at South Gyle and also in the centre of London in Interaxion. We've been a member of Links since 2005, so we've a fair bit of experience of actively peering on the London Internet Exchange, and we run a network that encompasses both Scotland and two sites in London, in Docklands and in the centre of London. Just so you know who I am and why I'm talking. Okay. Introductory, I was asked to talk about peering and about the benefits of peering, wanting to keep this a simple introduction. So I think that starts with how does the internet work, because the layman will bring up a browser page and browse the internet and probably has no idea what's going on behind the scenes. Behind the scenes, that website could be pulling content across all sorts of networks around the globe. What's actually going on behind the scenes? Well, the internet is fundamentally a network of networks. There's a bit of an urban myth that it was designed to survive a nuclear attack, which is not quite true, but the design did consider robustness, survivability, and what might happen if you lose a chunk of it or two of it at any given time. It is actually pretty damn reliable. So what do we mean by a network? It's a network of networks. What is a network? Well, anyone preparing a presentation naturally goes to Wikipedia for their content. So I looked up an autonomous system, and I was told it's a collection of connected internet protocol routing prefixes under the control of one or more network operators that present a common, clearly defined routing policy to the internet. Well, I think probably about half of you in the audience are okay with that definition, but it's a bit of a mouthful, so I thought I'd take that into plainer English. It's called an autonomous system. We're going to call it a network today. Typically, that would be an ISP. So that would be maybe Pulsant or Bright Solid or IFB or Virgin Media. It could be a hosting provider. It could be a content provider like Google or Netflix or something like that. It could be a data center, or it might be larger organizations might do this. But some of the bigger organizations will generally use an ISP for their internet connectivity. Why would you get into running one of these networks? Well, normally it's because you'd be wanting to multi-home. So you're wanting to take two internet circuits and sort of mesh them together for resilience, essentially. So typically, when you get into running a network like this, it's about multi-homing, but it could also be about peering, and we'll come on to more detail about peering and what that means. There are about 25,000 of these networks that form the internet globally. So that's not a massive number. There's not that many of them. Think about globally, the number of countries. I don't know, John, how many in the UK? Not even hundreds. So there's not that many of these. So it's a slightly specialist thing to be doing. It's not something that a small business would want to do, or even a mid-sized business would do. It's fairly technical. example, each one of these networks, these autonomous systems has a number. Here's some of the numbers for some of the people who are in the room today. Okay. So I guess answering the key question, how does the internet really work? How do you get from one of these networks to another one? If my company is going to connect to an ISP in Los Angeles across the internet, how is that going to happen? How is it possible? Well, peering is part of that. So peering is where two networks exchange traffic. So if I'm viewing a website and that website is hosted at another network, I'm looking at that, then there will be a connection between us. That connection could be on an internet exchange like Links, or it could be directly between the two companies if they literally ran a cable, fiber cable usually between them. And the larger networks will peer at a lot of different locations. A few of those Links, Amzix, and Decix, I don't know how you pronounce it, Frankfurt. Those are the main exchange hubs in Europe. You're seeing a lot of people connecting into those as hub points. So just to give us context, there's obviously a lot of UK providers will connect into Links. But you'll see in Germany, you'll see a lot of the Eastern European, Russian, ISPs, Polish, Eastern European connecting into Frankfurt. And you'll see a lot of the international networks coming to these three cities as the main internet nodes, where they're coming onto these exchanges to exchange traffic. Not quite a picture of the internet, but you've got these AS numbers, just to give you some feel as to how things connect. You might have heard of the context of different hops, but literally the traffic will hop between providers, so that we can get, say, from my company to a company in London, might take us off to New York and then off to Los Angeles. So you've got a center of the AS 3333 connecting to various what we call upstreams, and that they take the traffic onto other people who are their customers. Internet exchange, I think people sometimes think, there's this hub thing, or there's this box of wires or something. I just wanted to give some sort of geographic context to that. Now, this is a map of approximately half of Links's London network, and I just wanted to demonstrate that these are, I think these are all switches. Would that be? Yeah. Up the right, you've got a lot in Telehouse East, Telehouse West. Left, your left, we've got Telehouse North. That's all in Docklands. We've got Telecity. It then stretches out. It goes into Interaxion in the city. It goes out to Powergate in West London. It actually goes out to Equinix out in Slough. Equinix think that Slough is in London, but they're Americans, so we'll let them off. So London, Links, it's not just in one location. It's spread across a number of data centers. There's a lot of fiber running between those data centers. It's not the most complex network, but it's not. If someone says there's a problem at Links, there's all sorts of parts to Links, and to each of these different circles, to these switches, your internet providers will all be connecting to these this equipment. That's the links are on two networks for resilience, independent networks from two different network vendors. That's to give you an option to really have two independent networks that even at the hardware and the software stack level are independent. Slightly simpler diagram there on that one, but I think that is both are present in all the different sites that links are in London. Okay, so why would you peer? Say when we joined Link some 7-8 years ago, we were based up in Scotland. We were only hosting in Scotland, and we chose to take some backhaul circuits, some point-to-point circuits down to London. One of the reasons was to peer on links. We could have taken circuits from some of the ISPs that were up here, but we chose to take backhaul down to London, and a part of the story was to get onto links. So peering, it gives you more control. It's direct exchange of traffic without anyone else in the way. And I think my company, we're control freaks. We want to control whatever we can, whether it's the equipment or the software or the network. So we know if we are sending packets across to Virgin Media or to Microsoft or to whoever, we can see it's going across links and it's going straight to them. So we're not dependent on, in that case, on somebody else in the way. So more control, improving quality. We can control the physical route, so we knew the route that our traffic was taking. We were taking it down to London ourselves. A quicker path, lower latency, which is, I guess, really the response time, which is it's not critical when you're, say, browsing a web page, but when it comes onto things, we've got customers doing VoIP, doing video streaming, doing real-time card transactions, and if something goes blip or some milliseconds of extra delay, these guys are on the phone, so we really are kept on our toes in terms of making sure we know where the traffic's going and being in control of it. There is an element there can be an element of reducing costs, because in general, peering can be a bit cheaper than buying internet access, what the trade calls IP transit. Diversity and resilience. We have 3 or 4 upstream internet providers, but we also have links. We do a bit of traffic on links, so it just gives you another option where you can put traffic, you need to move traffic about between your providers. Technical contact. Well, yes, you can get quite a lot of sort of technical know-how and contacts and people who can give you advice. And if there are problems, and there have been times when links have had issues, being a member, we see people on the private discussion list saying, we're seeing packet loss, we're seeing a problem here, we're going to bring down our peering. And we then, if we've got our customers on the phone saying, what's going on, the internet's broken, then they take a great deal of comfort in us being able to say, there's a problem at links, we're pulling our links, we're rerouting that traffic, we've talked to someone at links, and this is the situation. And that as opposed to being able to say, oh, I think there's something wrong with the internet, I've called my provider, kind of gives you a bit of an edge. And peering, I think there's technical and a bit of marketing kudos. Traditionally, I think being a member of Lynx, so you made you kind of a part of being one of the bigger players, I guess, showing that you've got the technical stripes to know how to do that gives you a credibility. Okay, another list of names and numbers. Thought this is an interesting. I just want to give you a feel. As a mid-sized Scottish hosting company, if there is such a thing, we connect to Lynx, and I think we probably managed to peer off maybe about 25 to 30% of our traffic onto Lynx. Others will achieve more. It just depends on your profile of your traffic. Lynx is a bit of a magnet for international traffic. So ISPs from all continents, they are paying to get to London so they can connect to Lynx. And I mean, John and the guys have been doing a lot of promotion to all corners of the world to try and get some of these networks to connect into Lynx in London. So here we have a list of these are kind of national ISPs in their own countries. Telekom Austria, OTE is a dominant telco in Greece. Iceland Telecom, Aircom, Telekom Malaysia, a couple of the big Russian networks, Turk Telecom. These are all pretty much, they all peer with us in London. We are turning up on Lynx, and these people, we're able to get direct connectivity to all of these directly across Lynx, which is quite, it's quite good if we've got Greek customers, Israeli customers, Irish customers, to see that traffic is coming directly from their carrier into Lynx and then onto our network, reducing the number of hops, reducing the number of potential points where there could be contention or delay. That's a good thing. So let's give you some international dimension to what that peering has done for us. Talks about latency, round trip time, moment London to Edinburgh, 10 milliseconds, perhaps slightly less at the optical layer, 16 milliseconds if you're on a provider I won't name. Basically, Scottish Internet Exchange should be eliminating that delay, where we're basically, at the moment, we're sending all the traffic down to London, or some of it to Manchester, and it's coming right back up again. If you Scottish people viewing Scottish content, we've got this additional latency, which really we could do without. Latency is important for the gamers, computer gaming, in video, VoIP, remote desktop, that kind of applications. At the moment, it would all help, to reduce that. Okay. An exchange can be where what the trade calls eyeballs meet content. I love these terms, but eyeballs is the consumers that are looking at the website. So your consumer ISPs, BT, TalkTalk, Sky, Virgin, and increasingly, I think we're seeing on the mobile networks are going to be pulling a lot of content. Content providers like the BBC with iPlayer, Netflix, putting a huge amount of content through Lynx now, the hosters and the application. So that you're going to kind of think about that in terms of what that could mean for the Scottish Internet Exchange. Let's come on to that later, but I think if these eyeball networks can be convinced to peer in Scotland, then I think that might help then later bring some of the content players, because it makes no sense for everybody to be backhauling all this to London. All right, zooming through my peering overview. Not all peering will occur on an internet exchange. where it's across the links, equipment, or fabric, it's known as public peering. The alternative is private peering, which literally is one company's router being connected to another one, normally via fibre. I've said sling us a cable. And there's a lot of that goes down on in London, some of it under the auspices of links. So typically the bigger players, BT will connect to Virgin or to the much larger players. But if it makes sense, if you're doing multi-gigabits of traffic to somebody, then it's probably in their interests for you to get a direct connection going, say within Tally House in Docklands. Okay, so what do you need to peer on an exchange? I said before, it's not this autonomous system running one of these networks. It's not something your average SME is going to get into. You need a router and fairly decently spec'd enterprise carrier kind of router. You need to have some reason to do it. You're going to have some traffic, some customers. The cost, there is a cost to all of this, but you're also going to need some technical clues. You're going to be running BGP4 routing. That's at the sort of higher end of the Cisco and the Juniper syllabus. You're going to have some experience. When our company started out, we hired our CTO from South Africa, because at that time there was very, if any, available BGP4 skills in Scotland. And if you are peering, you don't have to peer with everyone. Open peering, you can say, yeah, I'll peer with anyone. Any takers, doesn't matter. I'm not fussy. And there's a route server on links which you can advertise your routes, and it then will kind of make them available to anybody who wants them. Selective peering, where you may be going to say, well, I'm only going to peer with you if you're a biggish player, or if you're doing a certain amount of traffic to me. Maybe not interested in peering with a small hosting company or a tiny ISP from somewhere exotic. Maybe you're not going to, because there is a bit of admin and work in setting up some of this peering. You've got to configure the routers, the routes, and just keep track of them all. And it's not a big deal, but there is some work in it. And then you've got very restricted peering, and we could do. I'd leave it to someone else to do. You could have an afternoon talking about tier 1 peering and what that means. But that is typically the global networks at the heart of the internet, who perform a key role in passing traffic between other networks, and their peering restrictions would be something like you've got to do tens of gigabits of traffic, and you've got to have a network that spans 3 continents, and you've got to be in at least 5 of these major cities worldwide if you want to peer with Sprint or Verizon or somebody of that ilk. Okay, I'm going to come to the end of my presentation. This is my view as running a company that has appeared on links for a while. Why we welcome a Scottish internet exchange? I think this is long overdue. There's been a few false starts on this over the years. It makes absolutely technical sense to peer off local traffic in Scotland, as I've said. And I think maybe as the traffic is now rising and we're seeing a lot of content in the likes of iPlayer, that traffic is undoubtedly growing at a fierce rate. So maybe now is the time. And I think there are strategic economic benefits for Scotland. I think it really is, a country should have its own internet exchange. It's almost, it should be that tick in the box needs to be there. And if Scottish Government are out, SDA are out, pushing the benefits of Scotland, it is something I think that we need to have. And I think we've perhaps missed an opportunity. Manchester has had an exchange Links have set up an exchange recently that's doing quite well. There's been a Manchester exchange for many years, and I've seen that become a bit of a second hub in the UK. I've seen data centres spring up in it. I've seen American hosters go to Manchester because it's a bit cheaper than London, but they still get good connectivity there. And I think that they've become a bit of a hub, and that has resulted in a lot of connectivity going that way. And we kind of maybe missed the boat a little bit there. And again, my own view, I strongly think that Link's involvement in getting this going now is important. I think Links brings a lot of technical credibility to this, much more so than if it was a non-profit group of small ISPs doing it. I think it brings the Links membership a large audience with existing contacts, brings technical expertise, it brings benefits of scale, and some of the administration is covered. This has been done in Manchester. The Manchester Exchange is the traffic is growing, it's credible, there's a good list of peers growing there. So, ladies and gentlemen, I think we need to just blooming well get this done, and I think the Links are the people to do it. Okay, well, thank you. Hopefully that's a useful overview and some views from me. Happy to take any questions now or later or in the bar.
Thanks, Andrew. I think we're going to have a Q&A after.
Yeah, you're going to give.
Before the
Okay.
break.